This instructional video is designed to show you how to determine a standard cell potential when given a voltaic cell written in cell notation. So the first step is to look at this and write out our two half-cell reactions. And once we have these written, we'll use the half reaction balance method to complete them. In the case of copper, it's pretty straightforward. All we need are electrons. This balances both mass and charge. For the nitrate, we're going to have to balance oxygen by adding in waters. So we have 2 water molecules. This gives me 3 oxygens and 3 oxygens. The next step then is to add in 4 hydrogens to balance here. And the only thing remaining then is to add in electrons, and in this case this side is neutral, this side has a positive 3 charge, so we will need to add in 3 electrons here. Now once we have the completed half reactions, the next step is to write both of these as reduction so that we can find them in the lookup table, which means that this half reaction must be reversed. So this has been written as reduction, and we can find any standard reduction potential table, and we find that this has an E cell standard of 0.96 volts. This is already written as a reduction. And we find this in the table as 0.34 volts. Both of these are positive. So the third step is to note that the overall cell potential, E cell standard, will be equal to the E standard for the cathode minus E standard for the anode. So now we just take these values. We have 0.34 volts minus 0.96 volts, and this gives us an E cell standard of negative 0.62 volts. And because we've now completed this and gotten a value, we see that the E cell standard is negative. That means that this is non-spontaneous. As written. So we would expect that with this half cell written in this way, we would not see a reaction proceed without some external force acting.